Hey everyone, isn't it just the best to play outside on a sunny day? The grass is warm, the sky is bright blue, and everything feels so cheerful. But have you ever been playing, maybe feeling a little sweaty, and looked up at that big, bright sun and wondered, why is the sun's sulfur monoxide hot? It's super, super, super far away, right? It looks like a tiny ball in the sky. So how can we feel its heat all the way down here on Earth? That is an amazing question, and today we're going on an adventure to find the answer. Are you ready? Let's blast off. First, let's get an idea of just how big our sun is. Imagine our planet Earth is a tiny little blueberry. If Earth is a blueberry, the sun would be a giant beach ball. It's enormous, over 100 times wider than our whole planet. The sun is a star, and it's the biggest, most important object in our solar system. Everything, including our Earth, circles around it. Now, let's zoom in. As we get closer, we see it's a giant, glowing ball of super hot gas. It's not solid like Earth. There's nowhere to land a spaceship. It's more like a fiery, swirling ocean of light and heat. Okay, put on your imaginary super-duper heat-proof spacesuit because we're going inside the sun. Deep down, in the very center, is a place called the core. And in the core, things are intense. The temperature is hotter than you can even imagine, millions and millions of degrees. It's so hot that nothing could survive there. Also, there's an incredible amount of pressure. It's like having a billion elephants standing on your head. This pressure squishes everything together so tightly. The sun is mostly made of a gas called hydrogen, and in the core, these tiny hydrogen atoms are packed together like sardines in a can, zipping around at incredible speeds. So, what happens when all these tiny hydrogen atoms are squished together in this super hot, super pressured place? They start bumping into each other really, really hard. Imagine billions of tiny race cars all crashing at once. When they crash with enough force, something magical happens. It's a process called nuclear fusion. That sounds like a big science word, but it's pretty simple. Fusion means to join together. Two of these tiny hydrogen atoms smash together and fuse, or join, to become a new, slightly bigger atom called helium. Helium is the same stuff you find in party balloons that makes them float. But here's the most important part. When this fusion happens, it releases a massive, gigantic burst of energy. Think of it like a tiny, tiny, tiny explosion. Now imagine this happening billions and billions of times every single second. All of those little explosions add up to create all the light and heat that the sun shines with. It's a giant, non-stop energy factory. This energy created in the core doesn't just stay there. It needs to get out. This energy starts its long journey from the center of the sun all the way to the outside, which is called the surface. This trip can take a really, really long time, hundreds of thousands of years. The energy bounces around from atom to atom, slowly making its way outwards. Once it finally reaches the surface, it's free. It escapes and shoots out into space in all directions. This energy travels in the form of light that we can see and heat that we can feel. It spreads out across the vast, empty darkness of space like ripples in a pond. It travels past Mercury, past Venus, and then it reaches us, right here on planet Earth. So why do we feel this heat when the sun is almost 93 million miles away? It's because Earth is in what scientists call the Goldilocks zone. It's not too close to the sun, where it would be scorching hot like the planet Mercury, and it's not too far away, where it would be freezing cold like Neptune. We are at just the right distance. The sunlight that travels all that way still has enough energy to warm us up. When the sun's rays reach us, they warm our skin. They warm up the air, which is why a summer day feels so nice. They warm the land, making the sand at the beach toasty. And they warm the oceans, which helps create our weather. Without the sun's warmth, Earth would just be a frozen, dark ball of ice. The sun gives us the perfect amount of heat for life to exist. It helps plants grow, gives us light to see, and of course, gives us those wonderful sunny days for playing outside. Now, because the sun is so powerful, we have to be very careful. It's super important to remember, never ever look directly at the sun. Its light is so strong it can hurt your eyes very badly. That's why we wear sunglasses on bright days. And when you're playing outside, it is always a good idea to take breaks in the shade and wear sunscreen to protect your skin from getting sunburned. The sun is our friend, but we have to respect its power. Here's a fun fact for you. Even though light is the fastest thing in the universe, it still takes about 8 minutes for the sun's light to travel all the way to Earth. That means if the sun were to magically turn off like a light switch, we wouldn't know about it for 8 whole minutes. Isn't that wild? So let's do a quick recap. The sun is a giant star that is incredibly hot inside its core. This heat and pressure cause tiny hydrogen atoms to smash together and fuse into helium, releasing a huge amount of energy. This energy travels to the sun's surface and then zooms through space as light and heat. Earth is at the perfect distance to catch just enough of that energy to warm our planet and make life possible. And that's why the sun feels so hot, even from millions of miles away. Science is so cool, right? Thank you so much for joining me on this amazing solar adventure. The universe is full of incredible mysteries. What other questions do you have about the sun, or space, or our planet? Let me know in the comments below. I can't wait to see what you're curious about. Don't forget to like this video and subscribe for more fun science explorations. See you next time.